Hello students, today we'll discuss the Excel practicals. So using MS Excel also we have some practicals. So today we'll start the practicals which are based on the MS Excel. So total we have using MS Excel we have total 5 practicals. So first we'll start with the first practical. So first practical is generation of random numbers. First practical is generation of random numbers. So in our theory class also we have generated the random numbers by using different formulas. So now we'll see how those random numbers can be generated in the MS Excel. So first coming to the generation of random numbers, first is in any generally in our theory class also we have basically started with the uniform random numbers. So first we generate the uniform random numbers between the interval 0 comma 1. So first I'll generate the uniform random numbers between the interval 0 comma 1. So you all are familiar with the MS Excel as we have done the practicals in our first sem and second sem also. So I'm not going all the basics. So here we'll have all the tabs. So from the data tab, you'll be finding here data analysis. So if this option is not available in the data tab, if data analysis is not available, what we do is from the file, you go to options. So from the options, here you will be having add-ins. So click on add-ins. So we want to add the analysis toolpack. So click on analysis toolpack, then here click on go and then click OK. You will get the analysis back here. So after adding that options, if it is not visible, once close the window and open it MS Excel again, you will find this data analysis pack in the data tab. So after getting the data analysis, so click on this data analysis. So you'll be having different types of data analysis in this. So in this data analysis, first click on generation, random number generation. So if you select random number generation, first number of variables. I want only one variable. I'm writing, suppose if X is one variable, under that X variable, I want to write the uniform random numbers. Suppose if you want X and Y, two different random variables, where you want two different uniform random numbers, you can select number of variables too. So I just want the only one variable, so I'm selecting the variable as 1. So number of random variables. That means how many random variables you want to be generated. So for example, I want some 15 random variables. So for instance, I'm typing 50. Next is distribution. So which type of random variables you want to find. So first I'm finding the uniform random variables, right? So select the uniform. So after selecting the uniform, here you get the parameters. So in parameters, I want the uniform random numbers between 0 to 1. So here between 0 and 1. So type 0 to 1. Next random seed. You avoid this random seed. Next output range. Here you have three different options. That is output range, or you want to display your output in any cell, or you can display your output in the next workbook also. So I want the output in this current sheet only. So I'll select output range. And if you click here, from where you want the output range? Here. So from here, I want the output range. So I'll select that cell, open it. Now click OK. So if you observe, you get the different random numbers between the interval 0 to 1. If you observe all the 15 values, whatever the 15 values are there, all are lying between 0 to 1. Suppose if you want only 4 digits after, if you want only 4 digits, once again, if you want only 4 digits in your, after the point, so select these values, right click on that, and then click on format cells. So in format cells, you want to format the number, click on number. So after decimal place, I want only 4 digits. So select 4 digits here and click OK. You will get the uniform random numbers between the interval 0 to 1. Next is, I want to find the uniform random numbers between the interval some a comma b. So let the suppose be from between 2 to 5. I want the uniform random numbers between the interval 0 to 5. So now same procedure, go to data, select data analysis. Now select random number generation. After selecting the random number generation, here I want obviously only one variable. I want 15 random numbers. My distribution is uniform distribution, but here the interval is, so the interval will be changing from 2 to 5. So 2 to 5, between the interval 2 and 5. Output range. So from where you want the output? I want the output from here. So select the cell, click here and then click on OK. We get the uniform random numbers between the interval 2 to 5. So this is finished. Now select these values, right click on it, format cells. In the number, I want only 4 decimal places. So I'll select 4. OK. So in this way, uniform random numbers can be generated between the interval 0 to 1 and also between the interval 2, 5. Next, I'll generate the Poisson. So I want to generate Poisson random numbers with some parameter. Let the parameter I consider as 3.5. I'm just doing it randomly. You can check with your own numbers also. Next, the Poisson, same data analysis. So generation of random numbers. Now number of variables is 1, number of random variables I want 15. So now I want the Poisson. So select the Poisson lambda. So in Poisson distribution, what is the parameter generally? The parameter is lambda. So what is that lambda value? You type that lambda value. So here in the question, they may specify generate Poisson 10 Poisson random numbers with parameter some 3.5, or they can also give it as generate random Poisson random numbers with mean 3.5, because lambda is nothing but the mean of the Poisson distribution. So if they specify mean and variance both are equal in the Poisson distribution, so that is nothing but the parameter lambda value. So if they give parameter value or mean value or variance value, 3 are same for the Poisson distribution. So what is the Poisson distribution? I took here 3.5. So type the lambda value as 3.5. Output range. So I want the output from here. So select the cell, open it. Now click on OK. We get the different Poisson numbers between with the parameter 3.5. So these are the different Poisson random numbers. Next, normal. So generally, normal distribution will be having two parameters. One is mean and another is variance. So here suppose the mean is 5, variance is some 16. So in the question, if they specify find the normal random variables with mean 5 and variance 16. If they specify variance, it is sigma square value. If they specify standard deviation, it is sigma value. Remember that one. So data analysis, random number generation. So 15 numbers I want. Which distribution? Normal. So normal distribution, mean. What is the mean value given? 5. And standard deviation. In the question, I said with variance 16. Root over variance will give you the standard deviation value. So root over 16 is nothing but 4. So write the standard deviation as 4. Now output range. Select the output range. Click on this from where you want the output. Open it, click OK. We get the different random numbers. So now this I got in pointed values. So I'll format these cells. Format cells number decimal point. I'll write it as 4. So these are the different random numbers, different generation of random numbers. You can generate uniform random numbers, Poisson and normal. So same we have done in our theory practicals also, that is manual practicals. So this is our first practical, that is generation of random numbers. So you have to clearly write down each and every step included in this. So here I have directly used the function that is from data and data analysis tool. But instead of that, you can find out the random number by using the function called rand. So by using the function rand between, you can generate the uniform. So you can generate the uniform random numbers. So if I get 0 to 1, if I by using this function rand between 0 to 1, I'll get this value. Similarly, if I type the rand between some other parameters also, I'll get different random numbers from 2 to suppose 4. So I'll get the different random numbers. So you can use the rand function, or at a time, if you want all the 10 values, you can use the data analysis in your data tools. So this is the first practical, that is generation of random numbers. So where we have generated uniform, Poisson and normal. Our next practical, second practical, is fitting of straight line. So this is our first practical. Next, second practical we are going to study is about the fitting of straight line and parabola. Second practical, fitting of straight line and parabola. So you can fit the straight line and parabola by using MS Excel also. So in our syllabus, in our manual practicals, we have done fitting of straight line and parabola by principle of least squares. Here also, same, by using the principle of least squares, we can fit the straight line and parabola just by some function, just by observing the function. By using some function, we can fit a straight line. So coming to that, first we'll enter our data for fitting the straight line. So different x and y values. So one value will be independent, one value will be dependent, one variable 0, 5, 10, 15, 20, 25, 30, 35, only 30. These are your x values. Now I'll type the different y values. 10, 14, 19, 25, 31, 36, and the last one is 39. These are the different x and y values. So for these values, for this data, I want to fit a straight line. If you observe here, x values and y values are given. They are not lengthy values, so you can no need of shift in origin and scale. Generally, if you have some year values, we use shift of origin and scale. So here there is no need. So select your data. So from selecting your data, go to insert. So from insert, you go to different types of chart and select a scatter. So from the scatter, select any type of chart. Your chart will be displayed. So, but I want the straight line equation. So for this, so it may be straight line or parabola or any type of curve. Till here, the procedure is same. That is, you will enter your data, then you will select your data, and from insert menu, you will go to, you will select scatter plot or scatter chart from the chart menu. So after that, a chart will be displayed. So here I just want to remove this grid lines so that will be clearly visible. I've removed the grid lines. So this is the line I got for the observed line. I want a straight line now. What I do is I will be clicking anywhere on this chart. After clicking, right click on it. Right click on the anywhere on your chart. Then you will get add a trend line. You select this option, that is add trend line. So in this add trend line, first thing is you will get trend line options. That is, in the trend line options, first type is the trend type. What is the trend you want to fit? That is, you want exponential curve, you want linear curve, you want logarithmic curve, or one second, add trend line. So whatever the type of trend line we want, we can choose from here. Then we want a linear. Straight line means, remember, it is always a linear curve. Straight line itself indicates linear. So select linear. Then here, come back to here, you have display equation on chart. We want a straight line equation. So if you select this linear, it will automatically draw a straight line. It will fit a straight line and draw a straight line for your data. And we want that equation. So check in this checkbox, that is display equation on chart. Then close. If you want other formattings, you can do other formats here. You can add the line color, line style, whatever you want. You can choose that. Now I want only display equation on chart. So I'm displaying and closing it. Now if you observe, here we get the equation. This is the equation. So this is a straight line equation. So I'm just enlarging this one. So this is the straight line equation we got, that is y equals to 1.0214 x plus 9.5357. That is y equals to a plus bx we write generally. In our format, in our theory classes, we have written the straight line form as a plus bx. So what is the a value? 9.5357. B value is 1.0404. Here the fitting of straight line is finished. Now if you want the trend values, so in the fitting of straight line also we have estimated values, right? How to estimate the values? First write down this equation. This is my equation. So this is the equation. And this is the straight line equation we get. That is y equals to 1.0214x plus 9.573. So here you observe, you get two lines. This blue color line is the observed line, and this black line, whatever you find, that is your fitted line. So if you want to find the trend values, what we do is equals to, you want the straight line equation. So where you'll be fitting the different values, that is 1.021 into 0214 into x. What is the x value here? This one, x plus 9.5357. This will is the first trend value. Similarly, you can find the remaining trend values also just by dragging. We use the same formula, the equation will be changed, only it will refer the different x values. So by dragging, we get the different trend values. So in the question also, if they ask to find out the particular value of y at x value, you directly substitute the x value here and can find out the y value. So in this way, we can find the straight line equation for the given data. Suppose we'll consider one more question where we do the shift of origin and scale. So here I'm entering the data, x values and y values are given here. So x values means the x values, different x values are given in years. Suppose the values are given in years 1997. Next is 1998. Similarly, I want the values up to 2003. So I'll just select these values and drag the values up to 2003. Next, y values. Now type the different y values. So the different y values are 80, 90, 92, 83, 94, 99, and 92. So if you observe here, the values are, they are very higher values. That is why you may getting the confusion that whether we can use the same procedure or not. So here what we can do is one thing, you can do as it is. So from the given data, select this data, from insert scatter, select any chart type. So from this chart type, you can click on add trend line. If you add trend line, select linear display equation, close. So equation, you will get the straight line equation. So here, if you observe, this is okay. You get 2x minus 3910. Lengthy calculation. You can use this value as it is, or one thing we can do is you can shift the values. Instead of using the x values as it is, you can write this x values as u values. That is u equals to x minus a. The a is nothing but the middle value, that is 2000. For every value, you can subtract with 2000 minus 2000. Similarly, here also same values you will get like this. So now for these two values, for u and y, we find the chart. So chart, insert, scatter plot, any type of chart like this. So here we get the, it is displayed in a reverse order. One second. Write your u values first. And next write down your y values. Select the data, insert, chart, scatter plot, select any type of scatter plot. So here you get a negative and the positive. So here I want the equation. Now if you type add trend line, if you click on add trend line, linear display equation, close, we get the trend line as 2x plus 90. So here the intercept value is decreased. So if you sometimes it is 3910 only, you can calculate easily. But sometimes you get the values as in calci also you get 10 power something like that. At that time it becomes difficult, right? So in some cases to avoid that one, we use this format that you will convert the shift of origin and scale values. Now the same thing, the same value you can use anything here. Here in place of x you need to consider u values. So this will be a equation that is 2x plus 90, not 2x here. We are using tu. If you're considering x, you consider this equation. If you're considering u, consider this equation. Sometimes we get a very lengthy values like E will be written in the MS Excel. So at that time, it will be again take some time to format the cells and round it off the values to decimal point 0. So it takes some more time. So that's why instead of that, whenever you have years, you can go for this procedure also. Whichever is comfortable, you can choose that one. So this is fitting of straight line. We get the straight line equation. So which can be done in two ways. If you have year values, just shift the origin and scale, you get this trend line. So for the same problem, we have got the two equations, one in terms of x and other in terms of u. Next, we'll see fitting of the parabola. So coming to fitting of parabola also, what is parabolic equation we have? Ax square plus bx plus c. So we fit the parabola. Now the first question, we need to fit a second degree parabola to the following data. The question is different x and y values are given. So if you want, you can just use the same data or you can change the data also. I'm just changing the data. Values are 1, 2, 3. So I want 1, 2, 3 values up to 9. Select the values, drag it up to 9, we get the values. Now type the y values. 2, 6, 7, 8, 10, 11, 11, 10, and 9. So for this data, now I want to fit a parabolic equation. So select with your data, insert, the procedure is same, scatter, and select any type of curve. So you got a parabolic curve, approximately a parabolic curve. Now to fit this, you want the equation, you have to fit the parabolic curve. So click on add trend line. So for add trend line, you select here polynomial. So second degree parabola, we want the second degree parabola, that is quadratic equation. So here order will be 2 itself. Second degree parabola means order will be 2. Now display equation close. So this is the required parabolic equation, that is equals to minus, if you want I'll just enlarge it. So this is the parabolic equation we get. That is y equals to minus 0.2673 x square plus 3.5232x minus 0.9286. So we have fitted the parabola. If you want the trend values, what we do by using this equation, we find the trend values. So how you find the trend values? I'll show it one value. For trend values, type equals to first. First is you want to type this value into x square, that is 0 minus 0.2673 into x square. X square means x into x into 1 into again 1 close the bracket. This is the first term plus second term is 3.5232 into x, that is this value close the bracket minus 0.9286. So this is the required equation. Now click enter, you will get the trend value as 2.32. You get the trend value 2.3276. Similarly, for the remaining values also, you can drag it. We get the different trend values. So these are the different trend values. So same thing, you can do it for the year-wise values also. If you have something years, if I have any question in terms of years, then you can find, you can shift the origin and scale, or if you don't want to shift the origin and scale also, you can directly do the problem. So I'll once show that one. Different values, year values, x values are given in terms of years and the corresponding y values. So what are the x values are 1997, 1998 up to, I want the values up to 2003. One values up to 2003. Next, I'll insert the y values. So what are the different y values we have? 42, 49, 62, 75. Next is 92. And the next value is 122. The next is 158. So these are the values. So for this, first I'll draw a parabolic curve. Normally, insert, scatter, and select the type of the chart. Now I'll add a trend line. Now I select polynomial of order 2 and display equation close. Now you consider this equation. If you observe, so this case will be happening mostly in the parabola only. So that's why it is better to use the shift of origin and scale. So this is the parabolic equation. If you observe this equation, you have the values in terms of E. That means these are some lengthy values. 1E plus 0.7. You have 1E plus 0.7. So this value is, if you want to change this value, you want to go to format cells, then number, and read the decimal point 0, click OK. Then we'll get this big number. So for this case, that's why what we do is, instead of using x and y values, I'm going to use the shift in origin and scale values. So how do we shift out origin and scale values? We have already seen for straight line. So here we write down the u values, that is u equals to x minus a. So a is the middle value is 2000 here also. So equals to this value minus 2000. You'll get minus 3. Similarly, you go with the remaining values also, we get all the u values. So as I said, first you need to have the independent variable. Next, you'll be having the dependent variable. So select these values. Now go to insert from scatter. Select the chart type. You'll get this chart like this because negative and positive axis both are included. Add trend line. Now click the polynomial of order 2. Then display equation on chart and close. Now we get this equation. So what is the equation we got it now? I'm just minimizing this one. So this is the equation I got, that is y equals to 2.833x square plus 18.71x plus 74.831. So if I use shift in origin and scale, I didn't get the e values. That because the values I have reduced, I have shifted the origin value. So that's why using this origin and scale will be easy for you. In case if you want to find the trend values, it will be helpful. Now use the for the trend values. So how we find the trend values here? Equals to, open the bracket, 2.833 into x square. So here what we are doing, u values in place of x we have considered u. So this value into this value again. Now close the bracket. Now plus 18.714. Oh shit. 18.714 into x. So 18.714 into x value is minus 3. Select this one, close the bracket. Next plus 74.381. Click enter, we get the trend value as 43.736. So in the same way, you can drag the remaining values, trend values. Select the first one from the bottom corner to the right side, drag the values, we get the different trend values. So if you don't shift your origin values, we get here 1e plus 0.7. So in this way, by shifting the origin, we can find the trend values easily. Otherwise, we get the very lengthy and big numbers. Now coming to the for this practical, so we have finished 2 practicals today, that is generation of random numbers and also fitting of the straight line and parabola. So 2 practicals are completed. So in the next class, we'll see the fitting of power curves. So which will be very similar to this power curve and exponential curves. And one more practical is related to correlation. So practice all these type of curves. Next, we'll see the remaining classes in our next session.